Good evening everybody. Myself Daksha Diwan, Assistant Professor in a Government Engineering College, Gandhinagar, Sector 28. Today I am taking the topic of calculus, which is very important for the engineering student, and that topic is partial derivative. In that partial derivative, you have learned so many things. In that topic, today I am taking the chain rule and Euler's theorem for the homogeneous function. So first, let me revise what is the meaning of the partial derivative. Partial derivative, that's very useful for the engineering student. There are so many applications in the engineering field. They are using in a partial differentiation, how to apply in a real life problem. That's very important for the partial derivative. So let's start our interesting and important topic for calculus. So let's see in our slides. What is the partial derivative? If f is a function of two variables, then its partial derivatives are the function of functions fx and fy defined by fx x comma y limit h tends to 0 f of x plus h comma y minus f xy whole upon h. If you remember the basic derivative dy by dx, उसमें हम लोग लेते थे dy by dx is a limit h tends to 0 f of x plus h minus fx upon h. So we have here two variables. We are using partial derivative always for more than one variable. Here we have two variables. So first we will take the derivative with respect to x and then with respect to y. Here you have given that f of x plus h. So we are taking little bit increment in a x, then the difference with the original function, and take the ratio with that smallest increment and then limit h tends to 0. So this is called the basic definition of the partial derivative with respect to x. Same thing for derivative with respect to y. So f y xy is equal to limit h tends to 0 f x plus x comma y plus h minus f of xy upon h. So here we are taking the little bit increment in a h, that is in a y form. So we are using the different notation for partial derivative. Suppose you have a z is equal to f of xy, then we will write fx in a suffix x, x comma y is equal to fx df del f by del x. We are using here del symbol for the partial derivative. When we are taking the simple derivative, we are using the d, and when you have a partial derivative, we are always using the symbol del is equal to del of f of xy upon del x, or we can use del z by del x is equal to f1 is equal to d1 f is equal to dx f. So we can use any one of this symbol for this partial derivative. Same thing for fy xy is equal to fy is equal to del f by del y is equal to del of function f of xy upon del y. Same thing we can write also del z by del y is equal to f2, or we can write d2f, or we can write dyf. So what we are doing in a partial derivative? When we are taking the partial derivative, there is a one condition is important, that is a more than one variable of the function. And here when we are taking the partial derivative with respect to x, So we will take the derivative with respect to x, and when all other variables are treated as a constant. Similarly, the partial derivative of f with respect to y, जब हमें y से डेरिवेटिव लेना होगा, then we are taking all other variables are a constant. I can give a simple example. If we are suppose playing the cricket, in a pitch we have two players. One is doing the batting and one is a supported one. So in that, what are the happening? One bowler coming and giving his ball. तो वहाँ पे सिर्फ जो बैटिंग करने वाला होगा वही सिर्फ उसको हिट करेगा बॉल को, सामने वाला सिर्फ उसको रन के लिए सपोर्ट करेगा. ऐसा नहीं होता कि यहाँ से भी बॉल हिट हुआ और वहाँ से भी हुआ, राइट? सो दैट इज नॉट लाइक अ बैडमिंटन, दैट इज अ क्रिकेट. Same thing happening here in a partial derivative. We are taking the one derivative with respect to x, keeping y constant. वो supported की तरह काम करेगा. And when we are taking derivative with respect to y, keeping x constant, right? So that thing happen in a partial derivative. Now in the next slide, we are taking one example. Find partial derivative at a point that find the values of del f by del x and del f by del y at a point 4, minus 5 if f of xy is given here x square plus 3xy plus y minus 1. The solution, we will take the first derivative with respect to x. So we are treating y as a constant. So del f by del x is equal to the derivative of x square is a 2x. Now the second term 3xy. So here derivative of x is 1, 3 as it is, y as it is, plus y. Y का derivative होगा 0 because we are treating as a constant, plus here is a minus 1, so derivative of constant is a 0. So answer is a 2x plus 3y. The value of del f by del x at the point 4, minus 5. So we can substitute now the value of x and y in this point, and then we have a answer is minus 7. Similarly, we can find del f by del y. We treat x as a constant. जब हमें y से डेरिवेटिव लेना होता है तब x को कांस्टेंट रखा जाता है. तो यहाँ पे x now will be constant and we are taking the derivative with respect to y. So derivative of x square will be 0. 3xy में y का derivative 1, 3 as it is, x as it is. Derivative of y is 1 and minus 1 का 0. So answer is a 3x plus 1. Putting the value of the point here, x is equal to 4. So answer is a 13. So we are doing the simple one example. Now we are going to our main topic, chain rule. आगे का हम लोगों ने थोड़ा रिपीटेशन लिया, जो पार्शियल डेरिवेटिव आपका ऑलरेडी टॉपिक हो चुका है. Now we are learning the next and important topic in a partial is a chain rule. Chain rule वो कहाँ पे हमें यूज़ करा जाता है? जब हमारा फंक्शन, when the function is a composite function, then we are using the chain rule. So for recalling the chain rule of the single variable gives the following rule for the differentiating a composite function. तो हम लोग we are recalling the basic of our 12th. If y is equal to fx and x is equal to g of t, where f and g are the differentiable functions, then y is indirectly a differentiable function of t. So we can see that f is a function of x, s is a function of t. So indirectly we can say the y is a function of t. So dy by dt is equal to dy by dx into dx by dt. This, I think, chain rule you already known from your 12th, right? Now we are using this chain rule in a partial derivative for more than one variables. For the function of more than one variable, the chain rule has several versions. We have so many types, several versions for this chain rule. So we are seeing one by one how it can be given here and useful to solve the examples. The first version deals with the case z is equal to f of xy. So we are taking here first thing, if z is a function of x and y and each of these variables x and y is in turn a function of variable t. So x and y is also the function of the t. That means z is indirectly the function of t. So we can write z is equal to f. In the place of x, we can write g of t. In the place of y, we can write h of t. And the chain rule gives a formula for the differentiating z as a function of t. So z is a function of indirectly it will be t. Suppose that w is equal to f of xy is a differentiable function of x and y, where we are taking x is equal to g of t, y is equal to h of t, are both differentiable function of t. Then w is also differentiable function of t, and we have dw by dt. Here w is a function of directly t, so that's why we are using the d here. जब सिंगल वेरिएबल होता है तो हम डेरिवेटिव में d सिंबल यूज करते हैं. If it is a more than one variable, then we are using del. Now w is also the function of x and y, so for that we are using del w by del x into dx by dt plus del w by del y into dy by dt. So for more than one variable we are using partial. For only the one independent variable we are using the d symbol, that is a dy by dx. So we can see the more thing in our next slide. So we can visualize this by diagram that w is a function of x and y. So that we are here two variables. That's why we are taking del w by del x and del w by del y. Here x and y is a function of t only. So we are using dx by dt and dy by dt. And then we have that rule. I hope we can understand that by diagram very easily. And now we will discuss one example for that rule. If z is equal to x square y plus 3x y raised to 4, where our x is equal to sin 2t and y is equal to cos t, then find dz by dt when t equal to 0. What is our chain rule? That is dz by dt is equal to del z by del x into dx by dt plus del z by del y into dy by dt. So first we will take the derivative of z with respect to x. What is our z? X square y plus 3x y raised to 4. So derivative of x square is a 2x, y will be as it is, plus derivative for this second term 3x y raised to 4. So it is a 3y raised to 4 because the derivative of x is 1. So that will be our first bracket. dx by dt. What is our x? That is sine 2t. Derivative of sine 2t is a cos 2t into 2 plus the derivative of z with respect to y. So our z is x square y plus 3xy raised to 4. In that x square behaving as a constant, derivative of y will be 1 plus 3 into x, that is as it is, y raised to 4 का होगा 4y cube. So 4 3 is 12, it will be 12xy cube. Now we have y is equal to cos t. The derivative of cos t is a minus sin t. So that we can solve the derivative. It's not necessary to substitute the expression for the x and y in the term of t. We can directly substitute the value. We know the sin 0 is 0 and cos 0 is 1. Substitute this value in our previous data. We have a 0 plus 3 into 2 cos 0 plus 0 plus 0 into minus sin 0. The answer will be 6. Now, suppose W is equal to f of x, y and z. In the previous rule, we took only the two variables, that is x and y. Here we are taking three variables, that W is equal to f of x, y and z is a differentiable function of x, y, z. Wherever x, y, z are the differentiable function of t, then W is a differentiable function of t, right? So dw by dt is equal to del w by del x into dx by dt plus del w by del y into dy by dt, plus we are adding this third term for z, that del w by del z into dz by dt. So we have that rule. We can easily understand by this diagram. Here we have a three roots